Current transformers are one of the most important equipment of power generation, transmission and distribution network. These are required to safely measure electrical power and to protect power network from faults. This equipment has very high status in the power industry as entire business of electricity distribution heavily depends upon the accuracy of this instrument. Justifying to its name, this equipment induces smaller currents in the secondary winding proportionate to the higher values of currents in the primary winding. By the way of shapes, we can classify these current transformers as ring type, bar primary or wound type CTs, or some more as per the requirement. By the way of application, you can classify like indoor type CTs, you must have seen them behind panels, and outdoor CTs found in overhead switchyards. By way of ratios, these CTs are available in almost any ratio you desire. In primary there are 80, 150, 200, 300, 400, 600, in fact 1000 and 2000 amperes are also available. But in secondary, only two options are available, 1 ampere and 5 ampere. You may select any of these CTs as per your requirement. Now, to understand the purpose of using CTs, let's quickly draw an 11 kV line network emanating from a substation. Here it is. Won't you like to know the load energy passing through this feeder? And shouldn't this feeder get tripped if any fault occurs on the line? Wouldn't it be fantastic? To fulfill both of these purposes, we need CTs. The first purpose is called metering and the second one is protection. Metering can be divided into two purposes. First is normal metering. It is required for measurement of load like ammeter. And the second is revenue metering. It is required to record the energy transmitted. You can easily understand that these CTs must be more accurate than others as financial implication is involved. Protection CTs also have two purposes to solve. First is to provide normal protection like overcurrent earth fault protection, and second is to provide special protection like differential protection schemes. Let's understand all these terms in detail one by one. You know that electrical faults are an unwanted feature of electrical circuits, and whenever it happens, primary current in the CTs reaches to the thousands of amperes. So connected metering equipments may get damaged. How to deal with this situation? You can understand that one option is to manufacture metering equipment capable of bearing such heavy fault currents, but it will surely increase the cost. Another option may be that this fault current should not get passed from these equipment so that smaller capacity equipment doesn't get damaged. But at the same time, you require feeder to get tripped or say protection CTs to work. Let's summarize all these requirements point-wise. Metering requires high accuracy, while moderate is okay for protection CTs. At the time of fault, heavy fault current should not get passed from the meters, while in relays it should reach properly. Hence, CTs are designed such that at the time of fault, when heavy current flows in the primary, its metering core gets saturated, due to which metering equipment gets saved as no current flows in it. But at the same time, relay gets a full current as protection core remains active. So, according to the accuracy classes, nomenclature of the metering class CTs is done as shown here. Normal protection CTs are usually available as 5P10, 5P20, while special protection CTs are simply called PS class CTs. Let's check it one by one. 531 class CTs are used in emitters for load monitoring purpose, while 0.2.1 class CTs are used for revenue metering. 0.2 class CT means that when the CT will be loaded with 100 to 125% load of its rated current, then at that moment the maximum error in its secondary current would be plus minus 0.2%. For example, if 100 ampere load is running on a 100 by 1 ampere ratio CT, then its secondary current may vary in between 0.998 ampere to 1.002 ampere. For primary loading less than 100% of the rated value, this error will increase. You may check out in this table. Normal protection CTs. Let's understand it by 5P20. Here 5 stands for composite error, P is the abbreviation of protection, and 20 is accuracy limit factor. Jointly, These three terms inform us that this protection class CT will not get saturated for 20 times of the rated current. And when such huge amount of current will be flowing in the primary of this CT, then the maximum composite error in the secondary of the CT would be plus minus 5%. For example, a 300 by 1 ampere ratio 5P20 CT would not get saturated for 20 into 300 equals to 6000 ampere fall current, and at this moment the maximum error in the secondary readings will be plus minus 5%. PS class CTs are designed for unit protection schemes like differential protection or REF. If you are acquainted with these heavy names, then you must be aware that in this scheme CTs are placed on the both side of the equipment to be protected. For example, HV and LV side of the transformer. Thereafter, differential relay continuously compares the values of currents received from both CTs. In case any fault occurs within these two CTs, the difference between two currents increases from the preset values and relay releases the trip command. But for all the faults outside of this zone, relay will not detect any difference between the two currents and will not release any command. Now you can easily imagine that to fulfill this requirement, it becomes very important that saturation characteristics and knee point level of both CTs must be identical. Let's read the nameplate details of this CT. These are primary and secondary terminals. This is a double ratio 2-core CT, 60 by 5 and 30 by 5. You can select any one of this ratio as per your requirement. Out of the two secondary cores, one is for metering, 0.5 class core, and the other one is for normal protection, 5P10 core. Burden of this CT is 15 VA. It means that total load on the secondary side of the CT should not be more than 15 VA. Load on CT secondary side includes relay, meter, and wire set, etc. This is the diagram to connect 3 overcurrent and 1 earth fault relays in the secondary side of the CT. This is just for your additional information. Relay, CT and breaker. How do these equipment communicate with each other to form a protection system? How tripping happens? You may click on this link to get a deep understanding. To understand various protections used for transformers, you may refer second video. We will meet again soon with another fantastic video. Till then, goodbye, thank you and take care.